the alphabet. And then we need to specify the position of the fluoro. And again, that numbering from the left is going to produce the lowest numbers. And the fluorine's at 3. We've got 2 methyls at position 2, making it 3-fluoro-2,2-dimethylhexane. Here our substituents again achieve their lowest possible numbering if we number from the left. And B for bromo, of course, is ahead of I for iodo in the alphabet. So we number this one again from the left. 4-bromo, 3-iodoheptane. Okay, so the fact that we named the one that was furthest away first is simply because B comes before I in the alphabet. We don't name them in their numerical order, but in their alphabetical order. Likewise here, we've got substituents which are down the bottom of the priority order ranking, and we simply name the substituents in alphabetical order. So chlorine before fluorine before nitro. But we then specify where they are appended to the chain. In this case, an 8-carbon chain, so it's octane. In this case here, the substituents are going to have lower numbers if they're numbered from the right, so this becomes carbon number 1. And we have this ability to use commas, which you've already seen a couple of times if we've got the same group. In this case, 2 bromine atoms. So it becomes 3,6-dibromo. Again, this is just alphabetical, which is ahead of 3-chloro and 4-nitro-nonane for the 9 carbons. So when we're naming the compound itself, naming the main chain of the compound, we need to indicate the number of carbons, and we need to choose the appropriate suffix to indicate the functional group that gives that compound its name and also indicates the highest ranking functional group. So, of course, we always give the functional group its lowest possible numbering. So that goes at position 1. There's 4 carbons in the main chain, hence bute. And the ol signifies that this is an alcohol, and that gets added as a suffix to the end of the name, to the end of the number of carbons in the chain. So putting it all together, the lowest possible, the start at the end, it gives the lowest possible number for the functional group. Specify the length of the chain, which we do with saying that there's 4 carbons by bute, and we add a suffix to indicate the type of compound it is based on its highest priority functional group. So, of course, if we've got 2 or more functional groups, we need to name it such that the highest priority functional group gets the lowest number. So here we've got the ketone group, we've got an alcohol, so we need to start from this end here and number this carbon number 1. So for carboxylic acids, we made a mention that we remove the E from the end of the parent alkane and add oic acid. So pentane with a carboxylic acid on the end becomes pentanoic acid. You don't need to number the position of the acid in this case, because the acid can't be extended and still be an acid. So it's always going to be at the end of the chain. So you don't just say 1 pentanoic acid. We know that the acid is at position 1. But you can, of course, have 2 acids in the same molecule, which makes them dioic acids. And again, you don't need to specify where they are because the acids will be on either end of the chain. And by definition, what the main chain is, because of the highest ranking functional group, we just merely need to specify the substituents. So this is 3-methyl heptane dioic acid, di meaning there's 2 acid groups. So for esters, we need to remove the E from the end of the name and add O8 as well, and we add the name of the group attached to the singly bonded oxygen at the front as well. So this carbon here will be carbon number 1. Chain will be named in that direction, and we need to say what's attached to the oxygen, which is an ethyl group. So this becomes ethyl pentanoate. Amides. So for amides, we remove the E and add amide. So pentane becomes pentamide. It's got the amide group on the end. It's possible, of course, to have alkyl or aryl, which are aromatic groups, attached to the nitrogen. And we indicate that it is attached to the nitrogen by adding the prefix N. Or if there's 2 identical groups, NN-. So for this molecule here, we've got an N-ethyl group appended on to the amide. And here we've got 2 of them. So this becomes NN diethyl pentamide. For aldehyde, we take off the E again and add this time al. So pentane becomes pentanal. Dialdehydes, dials, as expected. So here we've got the group heptane dial, the molecule heptane dial. In the case of ketones, we take the E off the name from the parent alkane and add -one. So pentane becomes pentanone. Of course, ketones aren't terminal on the chain. They occur in the middle of the chain somewhere. So we need to specify their position. And if we've got more than one ketone, so diketones, for example, become diones. So the molecule down the bottom left there, 2,4-octadione. And of course, to keep the lowest possible numbering for the molecule on the right, we number it from the left, and that becomes 2,6-octanedione. Alcohols and amines. So we've already had a look at a few alcohols. So for alcohols, we remove the E off the end of the name and add -ol. I'm sure you guys aren't going to forget alcohols. So the pentane becomes pentanol. And again, of course, it's not terminal, so we have to number it. So 3-pentanol. Dialcohols become diols, trialcohols, triols, etc., etc. And again, we number such that we give the lowest possible numbering. So this compound here is 1,3-butane diol. And here we've got 1,2,3 propane triol, which is, by its common name, glycerol. For amines, we remove the E at the end of the name and add amine. So pentane just becomes pentamine. But of course, it's an appendage. It's so it's can be terminal on the chain, but in this case it's not. So we need to say where